All right, legends. So this is the Bastian Cycles full interview. It's about an hour long. I put a snippet of this in, sort of like 3 or 4 minutes of this into a recent vlog last week, I think it was. And Bastian Cycles, man, they're an awesome bunch of guys. There's 3 guys that got made redundant from Toyota. And I contacted them because I thought, you know what an interesting story. They've taken their skills from the car industry, somehow applied them to the bicycle industry, and now they've got this prosperous cycling business where they manufacture bicycles. They do something very unique, and they do titanium lugs with carbon tubing, and they do pretty much most of it in-house. They outsource a little bit of it, but it's the engineering and their collective thought that's the interesting part, and the fact that they're trying to really make this work, and they're doing a good job of it. So I hope you enjoy this video. It's, as I say, it's just a series of clips put together, very interesting tales that have come out of it, their thoughts on other players within the industry, what materials they use and how they do that. So here it is.
This is our workshop or factory. Kind of works in a U shape. Everything comes in and then comes back out. This is our assembly area. It's Charlie putting a bike together at the moment. So, you know, we don't hold a lot of stock. Everything's custom. Being ex-Toyota, we try to run everything lean as possible. Gets us caught out every now and then. Not having parts when we need them, but we really try to hold minimal amount of stock and order as orders come in. This is our board where we track all the builds, so we have all the different steps in the process, and we keep track with little magnets of which bikes are on the go and what stage they're at, and then who's on, and then what task they're going to do for the day.
This is what I need at home.
Then we come through and we actually share space with Mark Hester from Postal Cycles. So this is his area. That's Mark. Mike, say hello. Maybe another story. He builds very cool steel bikes, also custom made. And coming through, that's our very old lathe, but it does the trick very well because it's belt driven. So the machining that we do, we don't really want a geared lathe. So we use, it's Australian made, it's from the 50s, but it still does the job. Over here's where we make carbon fiber chainstays on that machine over there in the side. This is one of our fixtures. We have another fixture there. Some testing equipment, blasting cabinet, paint booth, and then where we, I guess, cut carbon fiber to length, and then we have a vibratory finisher that we use to polish the lugs. So lugs come in from our supplier in New Zealand. Some of the tubing comes in from a supplier in Sydney. The chainstays we make in-house over here. So really, lugs come in, they get machined first. So we machine all the bearing seats, we tap all the threads. The threads are actually printed in, but then we chase them with a tap to clean them up. And then they go into a polishing process, which is a bit of die grinding by hand, a bit of linishing, a bit of vibratory finishing. I'll show you the machine if you come over, which is very loud, but this does a lot of the polishing work. So I'll just turn it on. And you can come in and have a look at it. So that just uses a cyclonic action with a very hard media that just, you know, through lots of high frequency vibrations, just grinds down the surface of the titanium. And so that does most of the work. It'll spend up to 24 hours in here, over 2 sessions. We usually do it at night because it's so loud. So we turn it on, come back in the morning, turn it off. So yeah, it's a reasonably expensive piece of kit, and it does a lot of the hard work, but yeah, we do still do a fair bit of hand work on the lugs as well. So that's the lugs, and then they're ready to be bonded. The tubing we have here, we cut to length based off a drawing. So we have tube drawings that tell us how long everything needs to be cut. Everything's cut to length and then sanded back, ready for bonding as well. So you can see the raw tube when it comes in is quite rough. Certainly not a premium aesthetic finish. There's ridges there from the heat shrink tape, which is used to cure the carbon fibre. So it's a lot of hand labour sanding that back. You know, our bikes look raw and when they're finished, you know, you can see the carbon fibre, but it's actually got clear coat on it to protect it from UV, but also to flatten out the surface and smooth it. Yeah. But of course, we're trying to build them as light as possible, so we don't just slather clear coat on and sand it once. You know, it's a 3-stage, 4-stage process to get it to the level. You know, we really try to be very careful and not sand through the pattern, because then those fibres, if we break those fibres, they're not doing anything anymore, and pretty much the whole length of the tube, they're rendered inoperable. Yeah. And so I guess when you are looking at bikes, there's other brands that use this tubing, same tubing. You'll often see the pattern has been completely destroyed because they've sanded right through it to get a nice flat surface for paint, but actually the tubes, it's probably still enough, but it would have lost some percentage of stiffness and potentially strength. Right. And so we spend a lot of time on the tubes to ensure that we maintain both the aesthetic and the performance of the tubing. So this is one of the tests that we do. This is simulating repeated brake forces on a frame. And so if we come over here to the jig, you can see 2 pneumatic cylinders with air lines coming in, running compressed air, which I can turn on for you. And basically this will push and pull, push and pull, push and pull. And you'll see the whole frame flexing. The top tube will bow up, the down tube will flex, the fork will move. It'll move 10, 15 millimeters each way. So the durability test is 60 kilos or 600 newtons forward and back, sustained for 100,000 cycles. So all our test bikes have done that. We don't do that test on customer bikes, but what we do as a proof test is we go to double that on every frame that we send out. So we go to 120 kilos or 1,200 newtons 5 times each direction. And we do that in a series of suite of tests to try and make sure that you know, there's nothing wrong with the bond. We haven't done anything wrong. I mean, we have process control, but just as a final check before they leave the factory, they go through a testing procedure. These are some lugs that have been in that's the finish that it comes out of the vibratory finisher. Yeah. So where's a raw one? No, I don't have a raw one on me, but so that's out of the vibratory finisher, and then that's after we bead blast them. Okay. And then a polished one, I don't have an example of right here, but we can also do a polished finish, which I think you got some shots of on the on James's bike. Yeah. And then we also we're open to painting the lugs, so that's one where we've done a black chrome finish. Okay. The one hanging up there.
That is stunning. That's
pretty nice. That's actually a respray. So the customer's seen the new finish we've developed and wanted it, so we've resprayed it for him.
Let's have a look at that.
So it's obviously still a work in progress, needs polishing, but and a final coat of clear. But that's black chrome and like a Ferrari red logo.
Gold. Isn't it?
So you can see how it sort of glints, and then like that's his nickname.
What's his nickname?
Bink. Yeah. Okay. So this is going to a client in Indonesia. Okay. Hopefully this week, probably next week. Still got a little bit of fine detailing to do. And then these 2 are for that green one that's on the test bench.
Okay.
Yeah.
So when you do your test, you said you're not actually testing like your durability testing? You're just making sure it's bonded properly.
For the end of line testing, yeah. For the durability testing, for the like during development, we're testing
Put on
fatigue.
that, and that's where it's just moving it.
Yeah, I'll turn it
100,000
on.
cycles.
I'll turn it on. So I'll just switch it on. So you can see how much the tubes are flexing and deflecting out of the way.
Yeah, you can slightly see it, eh?
Yeah.
So you do 100,000 cycles.
During development, yeah, the frames did 100,000 cycles of this. It takes about 3 or 4 days. We've got it going quite slow, but yeah, it's a significant amount of time. We do another one where we pull down on the seat. That's what this fixture's for. And that's done at a higher load, and that's to simulate, you know, your weight bouncing on the saddle. This is a raw one that needs clear coat, but it's been, so essentially that will come off, this should do. So that was once on there like that. So it's been wound on the machine over there, and then we pair it off in the middle, and then they come off. Not quite that easily, but they come off.
Put a bit of butter on it before you do it. So
Essentially, yeah, it's got a release coat on it, and there's a taper to help it get off.
Yeah.
But yeah, it's
really soft.
yeah. Yeah, and that's the thing. So it's very pliable in this direction, but if you try to pull that, it's extremely strong.
Yeah.
And so what the resin's doing is holding it so that in order to bend it, you have to stretch it, and it won't stretch. And so the resin's very important because it holds it in that shape. The resin's not very strong, but when you put the two together, the resin's holding this in such a way that you can't actually bend the finished part.
It's like reinforced
But you know,
concrete, really.
it's like reinforced
Yeah,
concrete,
yeah.
exactly.
Yeah.
That's also a composite, just a different kind of composite. The idea came about in 2014 when we heard that Toyota was going to be shutting down operations. They were going to be closing the technical centre where we worked, which was sort of Toyota's research and development facility here in Australia, out in Clayton. And so we had to, I guess, move on. It wasn't just Toyota. I mean, Ford's kept some engineering, and that's where Dean is, as I mentioned earlier. But most of the automotive work was drying up. And so we had offers to go to America, within Toyota, of course, to America, Japan, Europe. Quite a few of our colleagues took us up on those offers. But for the three of us, we'd all done a fair bit of travelling, living in Japan, living in Thailand, travelling all over, particularly the Southern Hemisphere. We didn't want to relocate ourselves and our families, and so you know, we're doing a fairly high level of engineering work, quite interesting work. There wasn't a lot of that level of work available even outside of the automotive industry, so we didn't really want to do what was out there either, and so it was, well, let's do something for ourselves, like this is our chance. There's not going to be another opportunity like this, and that is in the sense that we're kind of pushed into it. And then Toyota was very good. We got a decent, I guess, package as part of the shutdown, and so that gave us some capital to invest. And then we'd been riding together for years, and all passionate cyclists, and had always talked about bikes and different designs and what we would do if we would do one. And so it seemed like the perfect opportunity to take that step sideways, I guess, stay within engineering, but move from automotive into bicycles. It's terrifying. You know, it didn't happen overnight. It wasn't it's an emotional decision, of course. It's something that you want to do. You're following your passion, but it's something that you definitely consider very carefully. So I guess the more detailed origin story is I had the idea to do something in cycling, and I looked at all different products, but in the end definitely wanted to stay in Australia, definitely wanted to manufacture in Australia, and that meant it had to really be high-end niche production, low volume, high value add. And so the frame part of the bicycle equation, not components, not wheels, was the area that our skill set, or my skill set, and the two other guys that we ended up pairing up with, really lends itself the most to, and where we thought we could really make something world leading. And so I spent about 4 to 6 months doing a business model first to make sure that it was feasible from a financial perspective. And then Dean and I worked together in the same department, so we'd started discussing, and I was like, hey, what about this? What do you think? And he was pretty keen. And then the actual design side though, and the engineering side, I hadn't been on the tools, as we'd say, for quite a few years. I was in management and I wasn't doing much engineering anymore, and I couldn't do it, not to the level that this bike is. And James was the number one person I wanted to approach. And so
this is really where the Genesis story gets kind of interesting though, because Ben had done all this background work on the business and what does it make sense to make in Australia and at what volume and at what cost. That was all down on paper. Concurrently, unbeknownst, I'd already seen the technology was developing, and we were close to CSI Row at Toyota and seen a little bit of what they had there in terms of additive manufacturing, and the concept for the way the frame had already formed in my mind at the same time, independently in Ben's. I'd had a little bit of design work done, a little bit of CAD work done at home, and Ben said to me one day, right, let's go out for lunch. It's not unusual. We went out for lunch, 15 minutes into lunch, he starts pitching me this idea about a 3D printed bike, titanium, carbon fibre, and I was looking at him like, mate, I told you about this 3 months ago. You've forgotten where you got the idea, and you're pitching it to me, aren't you? But it wasn't the case. So we'd concurrently come up with the same idea. Obviously, Ben from a business feasibility point of view, and I had the design concept, so it was obvious that we were going to do it at that point.
Yeah.
And I think you say the fact that somebody else thought it was a good idea puts you over the edge for.
So I suppose most people, what I find interesting here is most people, they know that China, products coming out of China, you can go get a frame, you can get carbon, you can get titanium and stuff. But you guys are taking a completely different tack with a completely different design. And I assume you're talking about the 3D molded. What are these things called?
Well, yeah, additively manufactured. So we say 3D printed, but really it is additive manufacture. And the way that these titanium parts are made is with a powder bed system. So it's direct metal laser melting, where you start with a bed of dry powder, which is almost a talc powder-like consistency of titanium, and a laser will raster around and fuse layer by layer only the section of the parts that is being made, and then the whole bed moves down 50 micron, fresh powder's put on top, a laser comes around again and fuses material, and so the part is gradually fused together and built in a layer by layer fashion. And then at the end, build plate comes back out, wipe all the dry powder away that wasn't fused together, and at the end you've got a part basically.
Okay, so this sounds to me like a very expensive way of making a part. Is it expensive, and do you have to? Is that why your bikes are sort of at that higher?
It's expensive.
It's still expensive, but what Ben did well with the business model early on is understanding how expensive it is, and understanding how much fused titanium you can afford feasibly to put into a frame. And that put design constraints on how much titanium's in the frame and how.
So I'd benchmarked custom bikes, mass-produced bikes, worked out a price point that we thought was feasible from a sales perspective for the level of bike that it would be, and that then we worked back from that to achieve that price point. We need to be able to make the frame for this much, and then within that, I knew roughly how much it was per gram of 3D printing, and so then. From a business perspective, I was able to give James a budget, a design budget. So, the lugs have to weigh this amount and they have to fit within this envelope so that we can print them in this amount of hours. And so we designed the bike from the very beginning for the process to a budget, a high budget, but to a budget. And so I think that's why we've managed to as far as I know, we were the first to really truly commercialise a 3D printed bike. There'd been design studies done even before we had the idea. I mean, lots of people have had the idea. It's very easy to have an idea, let's do a 3D printed bike. Implementing it is extremely hard and took us a very long time to work out. Yeah.
But that's our background, and making things to a price point and to a timeline.
And I think that's why we took that different approach. Like you mentioned, a lot of people go and find an open mould frame, dress it up, and sell it, but they don't have 15 years of engineering experience. We'd be silly to waste that.
All right. So the big difference point that we're doing in our custom frames is they're a modular design.
Yeah.
With 3D printed titanium lugs, essentially.
Yeah.
And filament wound carbon fibre tubes in between that. So this method of construction that we're using lets us do custom geometry quite easily in one sense by changing the design of the lugs. And they're 3D printed, so there's no tooling or jigs or any moulds required to do different geometry for every single bike. So each bike that we make can be made with custom geometry.
Now, I have seen bikes where it's a similar sort of setup where they put the tubing on the inside of the lugs.
Yeah.
You've chosen to do the tubing on the outside. Is there a reason for that? Are we educating the market here and how to do it properly?
In terms of the bonding flange, there's two ways to do it. Well, there's a couple of ways to do it. On this road platform or road bike, we were pretty committed to try getting a flush finish between the titanium and the carbon tube, a flush transition without a step or anything like that. So that's the primary reason why we've got, bonding lugs on the inside of the carbon tube. But there's no reason that you couldn't do it as a double shear joint or bonding on the outside of the tube. It's just we can get a cleaner appearance.
Aesthetically, it looks better, but it also enables us to run our lattice all the way out to the end. So if that was a hole with a tube inside of it, we wouldn't be able to run any of this internal honeycomb or lattice inside the lug structure. And so that enables us to support it and run variable wall thickness in the areas of high stress. So it gives us a lot more design freedom when it's all hidden away as well.
Okay, so what does the honeycomb do?
So it's essentially the design. It's a thin-walled monocoque piece with a lattice on the inside to give it stiffness. So the lattice is built as the part is built, and it provides support for the material as it's built, but also results in a really high stiffness to weight ratio in the part. So it's kind of analogous to a composite panel where you have a stiff skin either side of a core.
Yeah.
It's just happening in 3 dimensions.
So do you aim to get a really stiff bike? What are you trying to? How do you get that balance between a stiff bike and a comfortable ride?
Depends what the customer wants.
It's tunable.
But the key fact is, the key point of difference is that it's tunable. So we do 3 types of layup in the carbon fibre tube. We have a regular, a stiff, and an extra stiff, depending on what the customer wants. And that, by changing the carbon fibre modulus and layup, we achieve those different 3 choices basically. But we don't necessarily have to trade off vertical compliance for torsional stiffness as much as you might do in a monocoque frame because of the modular design. The seat tube is one continuous piece all the way through. It's an ISP. We get excellent vertical compliance out of that, but then the torsional elements of the frame, the down tube and the chainstays, they're completely separate and different pieces. So these can be very stiff for out of the saddle sprinting and stiffness between the axles for cornering stability and cornering feel, but still a vertically compliant bike because the seat tube is a completely different member.
So this is actually part of your customisation of the bike, is that you can change this up.
Yeah, and then other things like top tube angle have a big influence on how comfortable the bike is. Changing the top tube angle, obviously you get more or less exposed seat mast. So that's part of the conversation with the customer when we're designing their bike. Some people want a really, horizontal top tube from an aesthetic point of view for a traditional looking bike, but that's fine. But if they want more vertical compliance, we can bring that top tube angle down and pinpoint, what point of vertical compliance they think is reasonable for the type of riding they're going to do, and then we compare that to other bikes that are on the market. So we've got data on the other major OEM bikes that are on the market. So if people have ridden the latest Canyon and they like how it rides, but they want it to be stiffer, then we can pinpoint the same compliance, but a little bit more torsionally stiff, or vice versa, whatever it is that they want.
Yeah, right. Okay.
Yeah, I think if we just, very simply, the feedback we'd had before starting this was that titanium and even steel bikes, everyone loves the ride quality. They're super smooth. And that's interesting because when you look at the stiffness of some of those bikes, they're actually stiffer than carbon bikes. They're heavier, they're stiffer. And so there is something about the material and the properties of the material that lends itself to that ride quality. And we narrowed it down to the damping characteristics or lack thereof. So carbon has a lot of inherent damping in it, which is...
What do you mean by damping?
So damping, it's like in your car when you have your shock absorbers or your dampers on your car. When you go over a bump, the damping settles it down. It absorbs energy and settles the car down. But too much of anything is bad. And damping tends to work well at certain conditions and not so well in other conditions. So if you hit a pothole or you hit a bump in the road, you want some damping in the bike because the whole bike's going to flex and go offline and get out of control. So carbon bikes are great for that. They damp that out. That spring and that motion is controlled. In a steel bike or a titanium bike, especially if they're not designed well, they can get quite sketchy. However, if you're on a coarse chip country road in Australia and it's quite a rough, asphalt surface, there's that constant road buzz that comes through on a carbon bike. We find like a bike or even a car, there's slightly different mechanisms, but it's essentially the same. In higher frequency, much faster sort of inputs, but small amplitudes. So not a big bump, just lots of little bumps. Titanium and steel bikes just glide over them and you barely feel them. On a carbon bike, you feel this buzz. And so you don't realise it. After a while, your brain just filters it out. It's constant noise, it's white noise, but at the end of the ride, you're actually quite tired because your brain's actually processing it, even though you're not, acutely aware of it because it's just used to it. And so we narrowed it down, our opinion. We haven't proven this scientifically, but the key contributor to that aspect of a titanium bike is actually the way the joints are constructed. And so by using titanium at the joints, we're able to achieve a lot of that smooth ride quality. All of our customers comment after a 60, 100k ride, they feel fresh, so much fresher than previously before. And then on the carbon, because we're not using titanium tubing, we've got the carbon tubing. On a bigger impact, when the whole frame has time and enough load to sort of twist and distort, the damping really comes into play. And so the other feedback we get is how stable they are, descending, how much stiffness there is out of the saddle. We're able to achieve that in a lightweight because we use the carbon fibre. And so it's really the best of both worlds. I'm very biased, but in my opinion, I've ridden some titanium frames and carbon frames, and it's different to either of that. It's not exactly like them and you put them together and you get our bike, but you really get a refined ride quality on them, which is what we're really encouraged to get feedback from everyone, from ex-pros down to weekend warriors, all give us the same feedback. So it tells us it's noticeable. It's not you have to be a rider that does 800 kilometres a week and be super sensitive to be able to pick up on it. Everyone from a weekend warrior to an ex-pro can notice it. We would have had to use the same amount of metal strength-wise as we do with titanium, but it would have weighed twice as much. Aluminium's lighter than titanium, but not as stiff. And then also when you pair aluminium with carbon fibre, the aluminium tends to corrode. So it's very tricky to do. It's not, The older bikes that were done this way in the 80s were often aluminium lugs with carbon fibre tubing, and the aluminium starts to degrade over time.
Pretty much a battery.
It creates a battery, So
there's galvanic corrosion between the two.
Probably a lot of people have had bid-on nuts
Of course.
go all white and crystallised, and your friend rails on about it all the time. Yeah, that's because they're aluminium. So we use stainless steel bid-on bolts, which is much less of a problem, and then we insulate them as well with epoxy. But if you had lugs made that way, they'd become a massive battery.
Yeah, right.
Yeah, he was really helpful to us in the beginning. Just, nothing necessarily formal, but he's been a really good sounding board, and he did some ultrasounds for us early on. And no, he's great. He knows his stuff. He helped us a little bit with choosing the adhesives that we use as well. Gave us some advice there. So no, he's been great. Oh, we admire heaps of companies for different things, but definitely Darren Baum and the way he produces bikes and the level of quality that he maintains is phenomenal. It's hard to get a close look at a lot of other bikes. They're not necessarily thick on the ground, but Firefly do some amazing stuff with anodizing and finishing of titanium. That's really cool. Fesca is probably as experimental as we are, or they're always trying new things, so we tend to watch what they're doing with some interest.
There's a few American builders that we've...
There's a few Speedwagon with their paint schemes and their fit tours, and they're always exciting with marketing and campaigns and what they're doing. They're very, very fun to follow. Look, it's I don't know how everyone around the world feels, but we've been to a few shows, and the custom bike world's actually kind of a nice community. Like, I think we all know that we're all doing something a little bit different, and often someone that wants our bike is not going to be interested in a Speedwagon, for example, or if they are, they want one of each, and they're going to get one of each. And so there's a little bit of a rising tide floats all boats mentality in general within custom bike builders, I find. Maybe we just haven't been around long enough to experience the flip side of that. But I think a lot of us are really chasing those customers that are spending big on more mass-produced bikes and trying to get them to experience something a little bit more bespoke and a little bit more niche. So we haven't really had any bad blood with anyone. It's been a really good journey from that respect globally. Everyone's friendly. We met Sasha from Speedwagon when he came out, and he was really friendly. We met the guys from Moots and the guys from Mosaic at different shows, and everyone's been really friendly, really open with information. No, it's a good environment. It's fun. And people might ask, why would we do that? Why would we, I guess, license what we've developed? But we see it's coming, and the worst thing is if people start doing it on their own and make a lot of the mistakes that we made during development, publicly, and then the technology will get a bad name, and that only hurts us. So we'd rather be part of the solution and part of helping, I guess, other brands start to use the technology as well. I mean, we're careful not to make it the same as ours. They need their own design ethos that we implement. But when we looked at custom bikes, one of the key things of them is they're personalised, and you're going to keep them. You're not going to sell them typically. They're going to keep them 15, 20, 25 years. They should last. And if something goes wrong, if you crash it or if you damage it, you want the bike back. You don't want another one. And so maybe it's not the best business model because we don't get to sell them another bike, but the bikes are repairable. And so we've built them modular, as James said earlier. We can replace tubes, we can replace lugs. And so, we're always developing with that in mind, is how to make it last. And we offer a lifetime repair guarantee to the original owner for that reason. I mean, we inscribe their names in the dropouts. Maybe it's a message that means something to them. It's really personal. And so, the bikes have to be built to last, and so that's something we take very seriously. Yeah, we 100% proof test every frame. So we don't do durability testing on every frame, but we do 100% proof testing, we call it, which is to make sure that all the bonds are correct and the bike's built to our standards. So I think we're the only company in the world that does that I know of. bigger companies do all the durability testing, of course, during during development, but in production they can't test 20,000 frames in a year. It takes too long, and the custom builders typically aren't doing much testing, and so we're kind of unique in that regard as well.
The epoxy that we use to bond the titanium and the carbon can be denatured at around 600 degrees Celsius quite easily, so we can debond the join, obviously at quite high temperature, and then the lug can be blasted back to its raw finish. And as Ben said, when it gets bonded back together, it's exactly as it would have been as a new frame, not with a patch, not with extra carbon or pieces over the top, different thicknesses and that kind of thing. It's as if it was new on the repair. As with most products, they're particularly bikes, they're designed for stiffness, not necessarily strength. So even if you've crushed your top tube and you've delaminated, 20%, 30%, half of your top tube, the bike will have lost stiffness. But it's still, what's remaining there still intact might be strong enough for it still to remain a bike, and you can still ride it and get away with it. So it's just a question of how much damage you've done as to whether, even with your seat stay example where you've crushed a seat stay and you're still riding it, it didn't completely let go and fall apart. It just became weak enough, or, it lost enough stiffness that you noticed.
You can feel it, yeah.
So obviously, once you've compromised the structure of whatever it is, it becomes a liability that it's going to get worse, and it might catastrophically fail when you're riding, so you should stop riding it. But
just with some of the tubing, you've obviously got the down tube is quite thick, and then you've got other, what is the rationale behind that? Obviously, looking at a couple of your frames here, the down tube is quite thick in comparison to other bikes.
So it goes back to that, I guess, discussion we were having before about being able to separate out the torsional stiffness of the frame and the vertical compliance. So on this road platform we've chosen quite a large diameter down tube, for example, and pretty tall chain stays, and that is to achieve the torsional stiffness of the frame that we're trying to get. But then other tubes and other member sizes have been designed for the compliance aspect. So pretty smaller seat stays, reasonably small seat tube with pretty thin wall. So each tube size and layup has been chosen and designed to achieve the stiffness targets that we're trying to get.
Okay. So
we did go through, in fact, Dean, our third business partner, went through a pretty intensive design study, because we have this is going to flip people out, we have a finite element model of the bike running in Excel, which may or may not mean anything to you, but we can iteratively do different carbon layups instantaneously in Excel and see what the effect of changing diameter, for example, or fibre modulus is on individual tubes one at a time, and then weigh that up. Is that stiffness gain worth the mass gain or not?
I reckon that Excel spreadsheet alone would be worth a good penny.
There are a couple other small builders that are interested in running their bikes through it.
Yeah.
We haven't licensed it out yet, but it's.
Who did that? Who's the Excel spreadsheet?
Dean, I'll kind of reluctantly admit that Dean, you're much better at Excel than I am, mate. Dean is, it's right up his alley to go deep and develop those kind of tools, which is, we've all, as much as the three of us are all engineers, we do kind of have complementary and overlapping skill sets in terms of where we're contributing to the business, so it's good.
Yeah.
The key point there is that we're not guessing. When someone comes to us and wants a bike, and we're going through the process of tuning it for them, from a geometry perspective and a stiffness perspective, we give them an engineering report, and in that report we tell them the results of the simulation. So it's not, we think this is going to be right for you, and then they ask why, and they say, well, this is how I build bikes. It's always that way. We spell it out for them, and we like it to be an educational experience about bike geometry, about bike stiffness. We really want it to be their bike, and so even when we're putting these suggestions forward, they're suggestions. We say like James brought up one of the ones we always hear is, people want a more horizontal top tube because classically bikes had horizontal top tubes, and increasingly now mass-produced bikes are getting more and more sloping top tubes. That's for a reason. They want more compliance and more comfort, but people don't like the look of it. And so actually we don't mind. We'll build a more horizontal, we'll build a more horizontal top tube, but we like to give the customer the information. So, okay, this is where we recommend, say 9 degrees sloping. If you want a flat one, this is what the effect is going to be on the comfort, and it's going to get stiffer. We'll say it's going to get 35% stiffer, for example, and it's going to be similar to this aero bike that's out there on the market that everyone says is brutally uncomfortable. And so we're able to put it into those sorts of terms for someone to understand, and so then they'll often, then we compromise in between, but it's their decision, and they're making it with all the information that they need. Like when people say, oh, you can't let the customer design their own bike, we're like, well, we can. They're not idiots. They know themselves better than anyone else. They know what they want. They just don't have the information they need to make the decision. And so our role is to give them the information in a way that they can absorb it and make a decision for themselves, because it's not our bike, it's our product, but we're really building it for them.
Maybe we should design a bike for Mark and send him an engineering report.
Wait, now you're talking. Now you're talking.
I'll take your measurements off your Canyon and we'll send you one.
Design one, not build one. We mentioned before we make some parts for other builders. The main part that we make is the dropouts, which I've got one here, the dropouts for the rear of the bike. So these are typically very hard to make in traditional manufacturing for custom builders. They often have a pins, they can do different geometries with, standard parts. And so we're able to give them options that are infinitely variable for all their custom bikes, and they're stiffer and lighter than a carbon one would be, much stiffer and lighter than a titanium one would be. They can be done in steel as well for steel builders. And that's where it saves the time. We spoke a little bit before about how the 3D printing is very expensive. It's our most expensive cost, but it saves time. Our labour cost is nowhere near what a traditional builders would be, where they've got to miter, file, weld, re-weld, paint. So I think a lot of builders are starting to realise for the more time-consuming, tricky components, this technology is quite valuable and actually works out a more cost-effective way of doing it, and performance increase.
So your doors are open to people who are manufacturing bikes to come and have a chat with you?
Yeah, not necessarily, to one-off people building a bike in the garage, because there's a fair bit of work involved, but for other builders that, as we said before, have a product, have a design ethos. They're not just, I guess, coming to the game and sort of just trying to leverage off us in that sense. It's a collaborative thing. That's what we're really looking for. Other businesses, that it's a collaborative effort where we're getting a bit of extra work out of it, but they're getting a lot of value, and they know what they're looking for, and they can come to us with a really good brief, and then we can work together. Yeah, that's something we're interested in. The advent of flat mount disc brakes has been a big one for custom builders. Trying to incorporate that into a welded frame has been quite tricky. And so you end up with something that's heavier, really time consuming to make. You're having to miter across tubes. It's very hard to do right. And for example, even carbon custom builders are making their own, machining them out of carbon, but we've seen some machined out of solid compressed carbon fibre that are well over 100 grams. Ours, for a flat mount dropout, is 55 or under 60 grams. So it's less than half of a carbon dropout. So people don't really often understand it. Because we can make it hollow and only thicken it where we need to for the high stress regions, we can actually make it cheaper and lighter and just as stiff, if not stiffer, than a carbon dropout. And definitely compared to a welded titanium one, it's an improvement.
Everything is computer controlled in the way the bike is. So obviously the print is computer controlled. It's the same every time. Our tubes are filament wound using computer control. So the fibre orientation is the same every time. And it's wound around a mandrel. So the inside of the tube is actually the tooling surface. So the inside of the tube looks better off the manual in the outside. So there's no warping of the fibres or voids or folded over fabric or any of those issues that you get with a monocoque.
If I went to Raoul, would he be saying the same things?
He'll back me up, but he'd say, well, your filament winding process better be well controlled, though.
Okay.
But obviously, in theory, there's no human hands laying down the ply or laying down the carbon fibre. It's controlled by computer.
Right.
So from that perspective, it's more repeatable.
Have you guys ruffled a few feathers in the traditional bike world with, obviously the giants and the Specialized of the world?
Oh, not that it's got back to us directly, I wouldn't think. I haven't heard anything.
Okay.
We, I think as Ben said before, we're happy to be friends with everybody. But fundamentally, we're still, a low volume producer. We can just about still name every customer that's out there on a Bastion, match their name with their bike number. So it's not something that Specialized and Giant are really worried about.
I've forgotten his name now, but the CEO of Giant in Taiwan.
Okay.
And him talking about the sales of their top of the line, SLR10, range of bikes. And the sales of that level of model aren't that dissimilar to the numbers that custom bike makers are doing. They might sell 40,000 Defy 2s, but of that top ranked one in any country, they're not selling huge numbers. And so, look, it is interesting. I don't know what effect, builders like us have on their. I'm sure we affect the sales of their top line bikes, but I don't think the sales of their top line bikes affect their bottom line very much.
They're essentially their hero product. So those top of the range, absolute top of the range Giant and Specialized, and the special editions that they do as well. There's so much R&D goes into them. It's maybe questionable whether they pay themselves off or not. But it's their hero products leading customers into buying the bulk.
Yeah. And that's then a question for you guys. Did you ever really consider that sort of majority of the market? Obviously your top end, these are top end sort of frames. So did you ever want to go after that market?
We fundamentally wanted to set out to do engineering and manufacturing in Melbourne, and as Ben said earlier, for that to make sense, it's got to be a niche, low volume product. Given that the developed economy that Australia is, that's what makes sense to make. But also the point that the technology's at the moment, the base cost is too high to be trying to make thousands per year. That's not to say that it might not change in the future, and obviously we're staying ahead of the curve on that as additive manufacturing technologies develop. It may become the most feasible and quickest and cheapest way to make bikes, but who's to say whether that's in 5 years or 25 years?
But in short, us as a company, at this stage, it's not interesting. We did this because we're passionate about two things: advanced engineering and bikes. And so we don't really want to be, dumbing down the technology to produce them cheaper. That's not interesting to us. And then, from a bikes perspective, we're passionate about bikes. We want to build the most amazing bikes we can. We don't want to take them back. And we come from a mass-produced environment at Toyota where we know what happens to an organisation when it starts to get that big. And it's fine, but it's just not something that we want from this place. Like James mentioned, we can still match bike numbers and customer names. I hope that doesn't change. At least within the last 12 months, we've still got track of that, because there's no greater satisfaction. Like we just did that at an event at Tour Down Under. We took 10 or 11 clients riding for 4 nights and 5 days. And at Toyota, I never got the experience to meet a customer, design and build a bike just for them, and then go riding it with them and hear them tell me what they thought of it, good or bad. I mean, mostly it was good. I don't think we had any bad feedback, but it's such a satisfying process, and it's just such a great thing to do for a living. It's amazing. So we don't want to lose that.
Of all the bike brands, and we're talking, you guys are obviously custom high-end bikes.
Sure.
in terms of the mass-produced bikes, who do you have the most respect for? I mean, let's talk about Specialized, for example. How do you feel about their engineering versus marketing?
Yeah, probably Specialized is probably the brand that I look to the most. Their bikes, when we've tested them, when we've ridden them, they're very well sorted. You know, I guess the practical, the physical representation matches the engineering, I guess, speak that's behind the bikes. The saddles are amazing. The bikes are light. They're as stiff as they say they are. They ride like they say they do.
And there's good rational engineering decisions behind most of their stuff.
Yeah, and they've got their own wind tunnel, and they do their own aero testing, and it really shows in the products. Yeah.
All right. Who are the other? Let's talk about the other ones though. The gimmicks.
Yeah.
Who's got the gimmicks?
There's definitely some other bigger companies that have a very strong marketing department. I think that probably influences some of the engineering decisions that happen and some of the things that get onto bikes where they're, you know, next season, what are we going to have that's going to make people upgrade to the next
bike?
You know, the next model, even though, you know, there's maybe not very sound engineering reasons to do some of the things that get implemented.
Who's this? Who are we talking about here, boys? Come on, let's name some names.
I'm not naming names.
Let's name some names. Shawnee, you can do it.
Yeah, even I'm not going to say it.
People can work it out. It's a pretty well-known brand that seems to like one set of letters, and they just use that for every model. So you can work it out.
Really?
No.
No comment?
No comment.
I'll tell you guys later the conversation that we had off screen. I'll tell you what they said. So at the moment you're sourcing your forks from China, is that right?
Yeah, some of our primary fork is an open mould fork that lots of other custom builders are using in a carbon fork. But we're also speccing the Envy flat mount fork now for some builds, and for the super light bike that is being released soon, it'll come standard with the Envy fork.
Okay. What makes a good fork? Like in terms of, you know, safety wise, I often worry about the fork snapping, you know, while I'm riding down a hill. Do you?
Well, obviously performance wise, stiffness is very important, and stiffness for weight, you know, at a reasonable weight. But something to look for in the design of the fork, particularly for the carbon fibre monocoque forks, is that transition across the shoulder of the fork into the steerer. And as Raoul would talk about, like, how are the fibres orientated around that joggle, and are they being asked to go around too many corners? And there's definitely some forks are better than others about managing that transition of fibre travelling up the fork and across the shoulder and into the crown. So you want to avoid the forks that look like they have stress concentration type right angles in them. That's not an ideally designed fork in our view.
Yeah, okay. So when these mass-produced companies come out with their bikes, how do you know, like, obviously the fork's one of the critical parts. You know, should we be getting every bike tested that we buy? And
well, there's definitely some brands doing a good job at scanning 100% of the product, particularly forks, like those safety critical components, and they have an X-ray scanner that they can see whether there's delaminated portions or, you know, plies in the wrong place. So that's definitely a strong point, something to look for if you know that your brand or your fork manufacturer is doing that. Okay,
so really when you buy a bike you should be asking, are you scanning?
It's a good question to ask, and it's pretty easy to find out on the internet which brands do that and which say nothing.
Yeah, forks are a tricky subject, because if something goes, you can lose complete control of the bike. Whereas elsewhere in the frame, you know, if something breaks, it's probably not going to be catastrophic. The fork and the stem, if those break, it's complete loss of control of the bike. So we've done some durability testing and things on the forks that we use, but it's always typically the forks are usually designed well enough. It's the process control, and so it's how well do they control that process. If their process is well controlled, then they all should come out the same. And so it's a difficult one.
So as Ben was saying, this is the one that I've built for myself.
Yeah.
It's an SL, a super light version of the current road bike. So the down tube, notice the down tube's a little bit smaller in diameter.
Okay.
And it uses different carbon fibre layup throughout the entire bike. A little bit thinner wall, higher modulus fibres everywhere.
Yep.
So it drops about 100 110 grams over a standard frame.
Okay.
So this bike in my size it's like a 62 centimetre, something like that.
Yeah.
With Durace hydraulic disc is 6.05 kilos, no pedals. So pretty.
Wow, that's pretty crazy.
Pretty light for a big bike, but
And that's with an integrated seat post as well.
yeah, with the ISP.
And an aluminium stem.
Yeah, and still with an aluminium stem. Cheating a little bit on the wheels. It's got a very light wheel set.
Does it?
It's got a 1,030 gram disc wheel set,
Yeah.
built by Dan at Shifter.
Yeah.
But this new super light frame set is going to, we think, allow some customers to get close to 5 kilos if they're quite a small rider. Yeah.
All right, so I'm going up to see James now. He has taken the measurements of my Canyon and he's hypothetically turning my Canyon into a Bastion. Is that right?
Yeah, that's the plan.
That's the plan?
Yeah, I think that's the plan.
He's got some fancy looking computer stuff going on here.
I measured off your bike, Mark, that your saddle setback, you've got it at 45 mil. You've got a bar drop of 110 mil, and 566 was the saddle tip to bar. You're running a saddle height. I got you at 758. You happy with that?
Mm-hmm.
We're graphing your bike for steering factor and response factor here, this little black square.
Yeah.
So compared to some other bikes on the market, it's a little bit more agile than these guys. And
Okay.
in steering factor, it's basically in the middle of our recommended zone, which is the box.
Yeah.
So if it's in the box, we're pretty happy.
Yeah.
And then in terms of stiffness, torsional stiffness, it's come out quite high, higher than a Cervelo R5, getting close to a Canyon Ultimate, but in vertical compliance, really good, like more comfortable than a Trek Monda
Okay.
up here. So that's using our stiff layup.
Yeah.
So if I change that, for example, I'll change that to our regular layup.
Yeah.
We'll watch where that black guy goes. Oh geez, we've got a fair bit. So we've traded down to the regular layup,
Yeah.
and we've traded off a lot of torsional stiffness. So now it's got still very good compliance, better than the Trek, but not as torsionally stiff as the Trek was. So we've dropped about 100 grams in carbon by doing that as well. So there's a trade-off there for mass. And of course, you've got to choose what you want in the custom in the dropouts, mate. What text do you want in the dropout? You put Maven or
Mavinator.
Mavinator. M-A-V-A-E.
M-A-V-E-N
Yeah.
A-T-O-R.
Righto. We'll put Bastion on the other side. We'll leave it as Bastion on the other side. Right. So
Just made that up.
from the XL development of the stiffness and the geometry, taken those numbers into CAD, thrown that in there, press OK, and we should go make a coffee because the computer's going to do the hard thinking. Here you go, Mark. That has regenerated. Oh, it's generated your bike cleanly first time, which is nice. And I'm not sure if the text has worked. Yep. So there you go.
Yes.
Mavinator.
This is the only thing I care about.
Yeah.
Can you see that? I don't know if we can see that. It's focus. It's got Mavinator on it.
Make it a different colour, James.
That's my new branding.
Yeah. The Mavinator. Oh,
Red, maybe.
no, it's too hard.
That's too
hard.
Yeah.
So from there, all those parts that have been generated need to be printed.
Yep.
So,
And that's it. It's as simple as that.
oh, jeez.
That was easy.
It was easy looking from where you are, yeah, maybe. But anyway, the parts that make up the bike, all the lug set, is they're arranged in their print orientation, one build plate. So that data gets exported and then and printed.
All right, legends, I hope you enjoyed that video. If you want to get in touch with the guys or you're interested in one of these bikes, they have said that they'll do a Maven discount code for us. So make sure you get in touch with the guys and let them know that you came through this video and they'll look after you on price. And I'll see you guys in the next video.